Good afternoon, everyone. Today we will be talking about Block 4, that is forecasting methods, which includes your four blocks, so four units. That is Unit 13, business forecasting, Unit 14, correlation, 15 is regression, and 16 is time series analysis. Now, the thing is that in Block 14 and 15, you will be having numerical component. And I request everyone today to have your copy, your notebook, and your pen ready with you because in maximum part of our today's session, we will be talking about the numerical component. As far as your business forecasting is concerned, what is meant by we here in forecasting, we have to predict the future by mathematical methods. In today's highly dynamic business environment, managers have to forecast the future and design strategies accordingly. The success of business depends mainly on future planning based on past and present experience. The experience may be based on quantitative and or qualitative factors. Both these both these types of information help managers in business forecasting. Managers use forecasting the art or science of predicting the future, techniques to take strategic decisions about selling, buying, hiring, etc. every day. The past data are used by managers to make predictions about the future. Forecasting is essential in order to make reliable and accurate estimates of what will happen in the future in the face of uncertainty. A flowchart of forecast and decision making processes shown over here. We make strategies. On strategies, we make decisions. Then we have planned performance, monitoring system, again, divergence, forecasts. But these two parts, that is, decisions and monitoring system, of gives the actual performance. Decisions are also get influenced by the additional information obtained by using the forecasting methods. Such information and the perceived accuracy of the forecast may also affect the strategy formulation of an organization. Thus, an organization needs to establish a monitoring system to compare planned performance with the actual. Some of the objectives of forecasting are: number one, the creation of plans of action because it is not possible to evolve a system of business control without an acceptable system of forecasting. Second one is monitoring of the continuing progress of action plan both on forecasts. And the third one is the forecast provides a warning system of the critical factors to be monitored regularly because they might drastically affect the performance of the plan. Now, what is the distinction between prediction, projection, forecast? First of all, we will take prediction. Prediction is a future estimate based on extrapolation. Hence, prediction is solely based on past data of the series under investigation. Projection is a prediction where an extrapolated value is subject to certain assumptions. And forecast is an estimate for some future point of time, partly based on past and present data, and partly on subjective estimates arising out of the experience and judgment of the forecaster. What are the steps in business forecasting? First one is to know the cause of change in the past. While attempting a forecast business fluctuation, a clear understanding about the causes responsible for past change is a must. Second one is to measure the phases of business activity. Having known the cause of occurrence of fluctuations, certain phases of business activity needs to be computed so as to forecast the change which are supposed to occur after the current level of activity. Third one is selection and compilation of data. The business barometers from the basis of statistical data available for measuring the fluctuations in business activity. The fourth one is analysis of data. The data needs to be in the light of one's understanding of the reasons why changes occur. If it is known that certain factors have resulted in a given change, then these factors are to be computed statistically to draw conclusions about the future. Now, what are the different methods for forecasting? Basically, they are quantitative, and the second one is qualitative. Quantitatives may be named as objectives, and qualitative can be named as subjective. There are different methods. We will see what are these methods. If we talk about qualitative forecasting methods, these methods consist of collecting the opinion and judgment of individuals who are expected to have the best knowledge of current activities or future plans of the organization. An important advantage of qualitative method is that they are easily understood. Another advantage is that they can incorporate subjective experiences as inputs along with the objective data. Again, the cost involved in forecasting is quite low. These methods have some limitations. One serious limitation is the varying perception of people involved in forecasting. Everybody has its own perception about the thing. I may say 40%, you may say 50%, third one will say 72%. So that means we don't have a same opinion about a particular thing. As a result, intuitive forecastings are likely to differ from one individual to another, and wide variance is found in the forecast. These methods are suitable when forecasts are to be made for highly technical products, which have a limited number of customers. Personal opinion. Here, an individual does some forecast which can be relatively reliable and accurate, of the future on the basis of his or her personal judgment without using a formal quantitative method. This approach is usually recommended when conditions in the past are not likely to hold in the future. Third one is panel consensus. To reduce the prejudice and ignorance that they arise in the individual judgments, it is possible to develop consensus among the group of individuals. Such a panel of individuals is encouraged to share information, opinion, and assumptions, if any are there, to predict future value of some variable under study. This is one of the methods, that is Delphi method. This method is very similar to panel consensus method. In the Delphi method, a group of experts who may be stationed in different locations and who do not interact with each other is constituted. That means these all panel members are unknown to each other. After this, a questionnaire is sent to each expert to seek his or her opinion about the matter under investigation. A summary is prepared on the basis of the written questionnaire from the experts. On the basis of this summary, a few more questions are to be included in the questionnaire, and the modified questionnaire is again sent back to the experts. This process, which generally keeps them informed of each other's forecasts, is repeated until the desirable consequences is reached. The Delphi method is an iterative procedure in which revisions are carried out by the experts till the coordinator gets a stable response. This method is very efficient if properly conducted, as it provides a systematic framework for collecting expert opinion. By virtue of anonymity, statistical analysis and feedback of the results, and provision for the forecast revision, results obtained are free from bias and generally reliable. Because the reason is the experts don't know each other and they have never met and they are unknown. Then comes your market research. The marketing research method is introduced in order to collect data, and accordingly, a well designed questionnaire is prepared and distributed among respondents. On the basis of the response obtained, a summary is prepared and the survey result is developed. Then comes your quantitative forecasting methods. These forecasting methods can be used under the following situations. Number one, past information about the variable being forecast is available. Number two, available information can be expressed numerically. Number three, a reasonable assumption is that the pattern of the past will continue also in the future. Forecasting for medium and short term decisions. Forecasting for the medium and short term horizons from 1 to 6 months ahead is commonly employed for production, planning, scheduling, and financial planning decisions in an organization. That means these are for the short term. We can classify these methods into five categories. First one, subjective of intuitive methods. Second one, methods based on averaging of past data. Third one, regression model on historical data. Fourth one, casual or econometric models. Fifth one, stochastic models with time series analysis and box Jackinson model. Subjective or intuitive method. These methods rely on the opinion of the concerned people and are quite popular in practice. Top executives, salesmen, distributors, and consumers could all be approached to give an estimate of the future demand of a product. That is, that can be done on discussion only. And a judicious aggregation adjustment of these opinions could be used to arrive at the forecast of future demand. Committees or even a Delphi panel could be constituted for the purpose. However, all such methods suffer from individual bias and subjectivity. It cannot be documented and programmed for use on a computer so that no matter whether A or B or C makes the forecast, the result is the same. However, subjective and intuitive methods have their own advantages. Marketing or other functional areas may be the only method available to forecast and plan future operations. Methods based on averaging of past data, that is exponential smoothing method. Exponential smoothing is another technique used to smooth a time series of its sharp variations. It is a type moving average forecasting technique which consists of a series of exponentially weighted moving averages. The exponential smoothing method weigh data from the previous time period and exponentially decreasing importance in the forecast. This method has a relative advantage over the methods of moving averages. First, this method focuses upon the most recent data. Second, during forecasting, this method takes into account all the observed values because each smoothing value is based upon the value observed previously. That means that has been recorded. This method is used for forecasting when there is no apparent trend or seasonal variation in the given value of a variable. However, this method is useful mostly for short term forecasting, like forecasting of sales, inventory price, etc. This is a relation with what normally we use, that is FT future value is equal to alpha D1 plus 1 minus alpha FT minus 1. Now the thing is that where alpha is a smoothing constant and its value lies between 0 and 1. But generally for the mathematical reason, we take its value as 0.01 and zero point 0.3. A higher value of a place more emphasis on recent data. In initiating smoothing, a starting value Ft is needed, which is generally taken as the first or some weighted demand value available. Another method often used in time series analysis is to identify the following four major components in a time series. First one is secular trend. Second one is cyclical fluctuations. Third one is seasonal variation. The fourth one is random or irregular variation. Basically, this is combination of four components. Now, how these four components are used. Okay. Now we move to unit 14, that is correlation. Here, mathematical expressions are going to, in correlation and regression, you have formulas and try to understand the concept. First of all, what is the meaning of correlation? Correlation refers to the associations between variables. When an association exists between two variables, it means that the average value of one variable changes as there is a change in the value of another variable. Correlation relation means that means they are somewhat related to something. So here we will be using mathematics, some mathematical terms and formulas for relating two variables. A correlation is the simplest type of association. When a correlation is weak, it means that the average value of one variable changes only slightly, only occasionally, in response to the change of the another variable. If there is no association, it means that there is no change in the values of one variable to the response to the changes in the other variable. In some cases, the correlation may be positive or it may be negative. A positive correlation means that one variable increases, the other variable increases. That is, height of a child increases with the age of the child. Negative correlation implies as one variable increases, the other variable decreases. That means value of the car decreases with the age of the car. Correlation and causation. Correlation between two variables measures the strength of the relationship between them, but it does not indicate the cause and effect relationship between the two variables. Relation correlation measures covariation, not causation. Causation means change in one variable affects or causes the changes in the other variable. In other words, just because two events or two things occur together does not imply that one is the cause of the other. What are the different types of correlation? Correlation may be a positive and negative correlation and linear and non-linear correlation. If two variables changes in the same direction, that is, if one increases, the other also increases, or if one decreases, the other also decreases, then this is called a positive correlation. For example, we can take advertising and sales. More you advertise the product, more sales will be there. Some other examples which are having positive correlation, that is height and weight. As the height increases, weight increases. Household income and expenditure, price and supply of commodity, and the amount of rainfall and yield of the crops. But these have positive correlation. If two variables change in the opposite direction, that is, if one increases, the other decreases, and vice versa, then the correlation is called negative correlation. For example, TV registration and cinema attendance. Some other examples which have negative correlation are volume and pressure of the perfect gas. Pressure is inversely proportional to the volume. Current and resistance, keeping the voltage constant. That is your Ohm's law. Price and demand of the goods. Then comes your linear and non-linear correlation. The nature of the graph gives us an idea of the linear type of correlation between two variables. If the graph is a straight line, that means a straight line, that is called a linear correlation. And if the graph is not a straight line, the correlation is a nonlinear or curvilinear correlation. In general, two variables x and y are said to be linearly related if there exists a relationship of the form y is equal to a plus bx. If we talk about a mathematical representation of it, this is basically a general form. This resembles to the general form of a straight line. That is y is equal to mx plus c, where we are talking about y is equal to a plus bx, where a and b are the real numbers. These are the constants. This is nothing but a straight line when plotted on a graph sheet with different values of x and y, or constant value of a and b. We will see it numerically. Remember, y is equal to of correlation. Though the coefficient of correlation we can measure the degree or extent of the correlation between the two variables. On the basis of the coefficients of correlation, we can also determine whether the correlation is positive or negative, and also its degree or extent. If we talk about perfect correlation, perfect means 1, and that too with sign of plus 1. If two variables changes in the same direction and in the same proportion, the correlation between the two is perfect positive. According to Carl Pearson, the coefficient of correlation in this case will be plus 1. On the other hand, if the variation changes in the opposite direction and in the same proportion, the correlation is perfect negative. That means in that case, it will be R. Carl Pearson coefficient is denoted by R, and that will be equal to minus 1. Absence of correlation, if you don't have any relation with them. If the two series of two variables exhibit no relation between them, or change in one variable does not lead to change in the other variable, then we can firmly say that there is no correlation or absurd correlation between the two variables. In that case, its value will be 0. Now, we have seen three values of r, that is plus 1, minus 1, and 0. That means we can say that the value of r lies between plus 1 and minus 1. Mathematically, it can be written as minus 1 less than equal to r. The plus minus signs are used to keep will be talking in mathematical terms. So you have to remember this. How? What is the extent of relation? If there is no relation, that means absence of correlation. Or minus 0.752. And on the other side, if we have negative correlation, its value will be from negative 0.75 to negative 1. If we have a moderate degree of correlation, it will be from plus 0.25 to plus 0.75. This is for positive correlation. And if we talk about negative correlation, it will be negative 0.25 to negative 0.75. And for low degree of correlation, its value will be from 0 to 0.25 or 0 to negative 0.25 for the negative correlation. You have to remember that R is a dimensionless quantity. That is, it does not depend upon the units employed. What are the properties of correlation coefficient? The correlation coefficient R lies between -1 and +1. A correlation coefficient R is a pure number and is independent of the units of the measurement of the variables. Third, correlation coefficient R is independent of change of origin. That is, the value of R is not affected if each of the individual values of two variables is increased or decreased by some non-zero constant. Number four, the correlation coefficient R is independent of change of scale. That is, the value of R is not affected even if each of the individual values of the two variables is multiplied or divided by some constant. It has to be non-zero. What are the methods of determining correlation? There are three methods. First one is scatter plot. Second one is Karl Pearson coefficient of correlation. And the third one is Spearman's rank correlation. We will start with scatter plot, that is scatter diagram or plot diagram. A scatter plot are used to graphically investigate the possible relationship between two variables without calculating any numerical value. That means, sorry, different values for x and y are given to you. You take x along the horizontal and y along the vertical with the particular scale, and you plot all the diagrams, all the points, all the values given on the graph. In this method, the value of two variables are plotted on the graph paper. Now, when this is plotted, you can see there are 6 types of figures here in this diagram. In the first one, you can see that is a perfect positive correlation. That means all the points are on a straight line. In the second diagram, you can see that there is a straight line, but maximum points are scattered around that straight line. In that case, we can say that this is a case of high degree of positive correlation. The third one you can see, no doubt they are moving up, but they are scattered. That means there is low degree of positive correlation. The third one, we see that the same graph is coming down. That means, and that too in a straight line. That is a perfect negative correlation. That means here R will be equal to -1. Adjacent to it is again a slope downwards, but the points are around that straight line. So that means high degree of negative correlation. And the last one, here you can say that the line is sloping downwards, but the points are scattered. In that case, that is a low degree of negative correlation. We have not calculated anything. We have simply plotted the points on the graph, and the conclusion is strong. But now, here you can see that all the points are scattered. If all the points are scattered, that means they don't have any relationship, or we can say that no correlation is there. Now comes your mathematical component. That is Karl Pearson's coefficient of correlation. It gives the precise numerical expression for the measure of correlation. It is denoted by R, and the value of R gives the magnitude of correlation, and its sign indicates its direction. If it is plus, moving up. If it is minus, coming down. And the mathematical formula, what you are supposed to remember is R is equal to summation of product of x and y divided by total number of terms into standard deviation of x and standard deviation of y. Here you can see that for small x is equal to x minus x bar. X bar is the mean. Similarly, y is equal to y minus y bar. Now the thing is that how to calculate standard deviation. Standard deviation is sigma x is equal to under root summation of x squared divided by n. Similarly for sigma y is equal to under root summation y squared divided by n. Now you can see in the last formula n is not there. Depending upon the calculation what you are doing and the problem which is given to you, you have to identify the formula to be used. By any of the method, your value is not going to change. But you have to keep one thing in mind. What is the nature of the problem given to you? Depending upon the nature of the problem, you have to identify the formula. There are three relations shown over here, and they are basically as per the question. First one is r is equal to summation of x minus x bar into y minus y bar. In short, we can say that xy divided by under root summation of x minus x bar into summation of y minus y bar. Y bar and x bar are the respective means of y and x. If we are using assume mean method, in that case we have to use this formula. Summation dx into dy minus summation dx dy divided by n, whole divided by summation dx square minus summation dx whole square divided by n into under root summation dy square minus summation dy's whole square divided by n. If you are using direct method, in that case, no dx will be there. You have to simply use the formula n times sigma xy minus sigma x sigma y divided by under roots n sigma x square minus sigma x whole square into under root n summation y square minus summation y whole square. You can see that these relations are in respect of each other are same, but depending upon its use, the formula has slightly changed. If we have covariance, what is the covariance between a relation? As I said, you can find R by different methods, but you have to identify the formula keeping in mind what is the nature of the problem. If covariance is given to you, so that means covariance of x and y between x and y is summation xi minus x bar into yi minus y bar divided by n. And your Spearman and your correlation coefficient will be r is equal to covariance of xy divided by s dx standard deviation y. Now we move to Spearman's rank correlation coefficient. Here you can see that a word rank is there. That means we will be talking in terms of rank. Again, two things come. Again, you have to see to the problem whether the rank is given to you or you have to calculate the rank. I'm repeating, depending upon the nature of the problem given to you, you have to identify whether the rank is given to you in the problem or you have to calculate the rank first. This method is based on the ranks of the items rather than on their actual values. The advantage of this method over the other is that it can be used even when the actual values of the item are unknown. For example, if you want to know the correlation between honesty and wisdom of boys of your class, you can use this method by giving them ranks to the boys. It can also be used to find the degree of agreement between the judgments of two examiners or two judges. The formula is for calculating the Spearman rank correlation is R is equal to 1 minus 6 sigma d square upon n into n square minus 1. Where R is the rank, D is the difference between the ranks of the two items, and n is the number of observations. Again, the same thing applies. Value of R will lie between minus 1 and plus 1. If you have R as plus 1, it is a perfect correlation or complete agreement in the same direction. R, if R is equal to minus 1, then there is a perfect negative correlation or complete agreement in the opposite direction. And if it R is equal to 0, then there is no correlation. Now for computing, give ranks to the values of the items. Generally, the item with the highest value is ranked as 1. And then the others are given to 1, 2, 3, 4 till the last. Then for since it will be a comparison, so you will be having two data with you, and for the first one you have to rank it as R1, and for the second you have to rank it as the R2. In the third column you have to calculate the rank or the difference between the rank. That means R1 minus R2. And you have to remember one thing, that summation of D, when you will be adding all the differences, it has to be 0. Then you have to calculate D square, and then you have to add all the values of D square, and then you have to apply the formula. Now we will see whatever we have discussed right now works. From the following information, find the correlation coefficient between advertisement expenses and the sales volume using Carl Pearson coefficient of correlation method. If you remember, at the beginning of this session, I said that there is a correlation between sales and expenses. This is what you have to remember, whether it is a positive correlation or a negative correlation. Now, this is the data which is given to you. That is, we are talking about 10 firms. Advertisement expenses in lakhs is given to you, and the sales volume in lakhs is given to you. You have to calculate the Carl Pearson coefficient, and you have to check it whether what was taught to you in theory is practically applicable or not. Now see what we will be doing. We will be transforming it like this. There are 10 firms, no problem. X and Y are the two values. For X, we are assuming the expenditure, and for the Y, we are assuming as the sales. Okay. Now what we are doing? You can see that these numbers are too big. So we have to calculate. First of all, we have to calculate mean. X bar is summation of X divided by N. Summation of X is 140. That means you will be adding all the values of X. And number of terms are 10. That means 140 divided by 10, which comes out to be 40. This is for X bar. Similarly, you have to do for Y bar. Y bar is summation Y upon N, which comes out to be summation Y is 500, 580. So number of terms are 10. So its mean will be y bar equal to 580 divided by 10, which is 58. Third, then you have to calculate x square. That means minus 3 square is 9. You have to square all these values. You will get this. Y has been calculated. Y is equal to y minus y bar. You get these values. Square it. And multiply x and y. This and this. Minus 3 and minus 8. Minus 3 into minus 8 will be 24. Then make this column. These two have been used. Now these columns has been generated. Now you have to remember that summation x square is 22, summation y square is 360, and summation xy is 70. So we will be using this relation. Summation xy upon summation x square summation y square, where your small x is equal to x minus x bar, small y, capital Y is equal to y minus y bar. You have the value of summation xy is 70, summation x square is 22, and summation y square is 360. That means 70 upon under root product of 22 and 360. After solving, you will get a value as 0.7866. You can take values, two values after the decimal. That means it becomes 0.78. Now, if you remember that during our discussion I said that there is a perfect correlation between advertisement, expenditure and sales. This is you can see that. Valuation plus, it is more than 0.75. That means if it is more than 0.75, it is a perfect correlation. That means positive direction. That means increase in advertisement expenses leads to increased sales volume. This was told to you in theory, and practically with an example you have seen over here. Now comes regression. Regression analysis is a statistical method that helps us to analyze and understand the relationship between two variables of interest. Now, this is very interesting. You have to understand it. What correlation is and what regression is. The process that is adapted to perform regression analysis helps to understand which factors are important and which factor can be ignored and how they are influencing each other. Example, we can say that age and height can be described using a linear regression order. Since a person's height increases as its age increases, they have a linear relationship. Regression models are commonly used as a statistical proof of claims regarding everyday's fact. A researcher might administer various dosages of a certain drug to patients and observe how their blood pressure responds. This can be broadly classified into two major types: linear regression and logistic regression. Now, what is the difference between correlation and regression? There is a very minute difference, but that difference is too much for a calculation. It measures the degree. We are talking about correlation first. It measures the degree and direction of relationship between the two variables. It is a relative measure showing association between two variables. Thirdly, correlation coefficient is independent of change of both the origins and the scale. Correlation coefficient is independent of units of measurement, but that is a ratio. unit doesn't come into the picture. Expression of the relationship between the variables ranges from -1 and +1. And correlation is not a forecasting device. And now, if we talk in terms of regression, it measures the nature and extent of average relationship between the two or more terms of the original unit of the data. It is an absolute measure of relationship. Regression coefficient is independent of change of origin but not scale. Regression coefficient is not independent of unit of measurement. Expression of the relationship between the variables may be in any of the form. It can be a linear relation, that is y is equal to a plus bx, or it can be a quadratic equation, that means y is equal to a plus bx plus cx squared. It is a forecasting device which can be used to predict the value of dependent variables from the given value of independent variables. We will see to it how it works. Regression lines and regression equations. Regression lines and equations are used synonymously. Regression equations are algebraic expressions of regression lines. Let us consider variable x and y, and we assume that y depends on x. The result comes in the form of a simple regression. If we take the case of two variables x and y, and we shall have two regression lines, as the regression line of x of y and regression line of y on x. The regression line on y on x gives the most probable value of y for the given value of x, and the regression line of x on y gives the most probable value of x for given value of y. That is why we have two regression lines. However, when there is either perfect positive or perfect negative correlation between the two variables, the two regression lines will coincide and we will have one line. That means these two lines will be one over the another. If the variables are independent, r is 0, and the lines of regression are at right angles, that is parallel to x and y axis. Now, there comes the relation between regression line of y on x. This line gives the probable value of y, dependent variable, for any given value of x, that is independent variable. We will get a regression line of y on x. That is mathematically formed by y minus y bar is equal to byx. See to the terms how it is written. Y minus y bar is equal to byx into x minus x bar, which is similar to a straight line of the form y is equal to a plus bx. If we talk for regression line of x on y, the line gives the probable value of x, that is the dependent variable, for any given value of y, that is independent variable. Here it will be regression line on x on y, which is x minus x bar is equal to bxy into y minus y bar. See the change between the two lines. And here it will be in the form of x is equal to a plus by. In the above two regression lines or regression equations, there are two regression parameters, which are a and b. Here A is unknown constant and B, which is also denoted by Byx or Bxy, is also another unknown constant, popularly called as regression coefficient. Here, these A and B are two unknown constants, that is, are fixed numerical values, which determine the position of the line completely. The parameter A determines the level of the fitted line, that is, the distance of the line directly above or below the origin. The parameter B determines the slope of the line, that is, the change in y on unit change in x. If the values of constant A and B are obtained, then the line is completely determined. But the question is how to obtain these values, and the answer is provided by least square method. Here you can see if we talk for x and y. First of all, from the given data, we have to calculate summation x is equal to NA plus B summation y. And second equation will be summation of xy is equal to summation A summation x minus B summation y square. And when you will be calculating for y on x, it will be summation y is equal to NA plus B summation x. The second equation will be summation xy equal to A summation x plus B summation xy. See the differences. That is why I've written together. Okay, how they are different and how they are calculated. We will be getting two equations. We will be simultaneously solving, and we will be finding the value of A and B, and then this line will be formed. Your final answer will be formed. The above method is popularly known as direct method, which becomes quite cumbersome when the values of x and y are large. This works can be simplified if, instead of dealing with actual values of x and y, we take the deviations of x and y series from the respective values, respective means. So here we can write it. Your equation is y is equal to a plus bx. We change it into y minus y bar is equal to byx into x minus x bar. And for regression equation x and y, x is equal to a plus by. That will change to x minus x bar is equal to b xy into y minus y bar. In this new form of regression equations, we need to compute only one parameter, that is b, which is also denoted by byx or bxy, which is called the regression coefficient. Regression coefficient, a quantity b in the regression equation is called the regression coefficient or slope coefficient. Since these two regression equations, therefore we have two regression coefficients. Regression coefficient of x on y, symbolically it is written as bxy. And regression coefficient y on x, it is written as byx. Now here, that is the gist of what we have discussed. If we have to calculate value of r, then what should we have? We should have bxy, sigma x, sigma y. So that is if standard deviation and correlation coefficient are known to you. You can straight away calculate it. Bxy is equal to r times sigma x upon sigma y. And your byx is the direct method using the sum of x and y. It will be bxy is equal to n times of summation xy minus summation x summation y divided by n summation y square minus summation y's whole square. And your bxy will be equal to summation xy upon summation y square when The deviations are taken from the arithmetic mean. Similarly, you will be calculating for y on x, but you have to remember the formulas. What is the properties of regression coefficients? The coefficient of correlation is a geometric mean of the two regression coefficients. That means R is equal to summation of xy into summation of byx. If one of the regression coefficient is greater than unity, the other one be less than unity. These three, four steps you have to remember because you will be calculating it mathematically and there is a probability of doing mistakes. If you know what you are doing, very good. If you don't know, then you have to remember the properties. If one of the regression coefficient is greater than unity, the other must be less than unity. Since the value of coefficient of correlation cannot exceed unity, both the regression coefficients will have the same sign. If you get bxy as plus and byx as negative, there is something wrong with your calculation because theory says they should have the same sign. In other words, it is not possible that one of the regression coefficient is having the minus sign and the other one is having a plus sign. The coefficient of correlation will have the same sign. The sign that is of bxy and byx, same sign will be for r. The coefficient of correlation will have the same sign and so as that of the coefficients. That is, if the regression coefficient have a negative sign, r will have a negative sign. And if they have positive sign, then r will be a positive sign. Now we will be going to solve a problem. That is, we will be estimating the future value. Now see, after investigation, after investigation, it has been found that the demand for automobiles in a city depends mainly, if not entirely, upon the number of families residing in that city. Below is are the given figures for the sales of automobiles in the five cities for the year 2019 and the number of families residing in these cities. We have Belagavi, Bangalore, Hubli, Kalaburagi, Mangalore, and number of families in lakhs is 70, 75, 80, 60, and 90. And we have the sales for automobiles in thousands, that is 25.2, 28.6, 30.2, 22.3, 35.5. Now, from this data, fit a linear regression equation of y on x by the least square method and estimate the sales for the year 2020. We have till the value of we have the value of data for 2019 and we are being asked to calculate it for 2020 for the city Belagavi, which is estimated to have 100 lakhs families, assuming that the same relationship holds true. Correct? Now we will be picking up this data. This data has been picked up. X and y. You are squaring x and you have to multiply x and y because we have to calculate the value of a and b first and then we will be moving to y is equal to a plus bx. This is what we are supposed to do. So first of all, we have to for finding out the value of a and b, we have to use least square method, and these have summation y is equal to na plus b summation x. And the second one is summation xy is equal to a summation x plus b summation x squared. From the top, we can get the values of 141.7 is equal to, there are 5 observations, 5a plus 375b. And for the second one, you have 108,849 is equal to 375a plus 28625b. These values have been calculated over here. Now, these two equations have to be simultaneously solved to calculate the value of a and b. After simultaneously solving these equations, we will get a is equal to minus 4.885 and b equal to 0.443. That means we get an equation as y is equal to minus 4.885 plus 0.443x. Now, what was the problem given to us? We were asked to estimate the value of 2020 for the city of Belagavi, where we will be having 100 families. So, what is the for you have to replace x by 100 over here. That means after calculation, you will get as y is equal to minus 4.885 plus 44.3, which comes out to be y is equal to 39.415. Now we will see whether our solution is correct or not. You remember y is equal to 39.415. See over here. We are talking about Belagavi. When you were having 70 families, you are getting 25.2. Now you are having 100 families and you are getting 39.45. That means this is a positive correlation. Family increases, your volume of sales increases. Then comes time series analysis. A time series is a sequence of data points measured typically at successive items, spaced at uniform time intervals. The time interval may be an hour, a day, a week, a month, or a year, depending upon the purpose of data collection. Most commonly, a time series is a sequence taken at successive, equally spaced points in time. Thus, it is a sequence of discrete time data. Example of time series is used in pattern recognition, signal processing, weather forecasting, and earthquake predictions. Time series analysis comprises methods for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. It is used to detect patterns of change in statistical information over regular intervals of time. These patterns help us in arriving at an estimate for the future so as to cope up with the uncertainty about the future. Time series forecasting is the use of model to forecast future events based on known past events. That is to predict data points before they are made. An example of time series forecasting in econometrics is predicting the opening price of stock based on its past performance. Forecasting is an essential tool in strategic planning and decision-making process of an organization. Now, what are the application of time series? Various application of time series are there. Economic forecasting, sales forecasting, budgetary analysis, stock market analysis, yield projections, process and quality control, inventory studies, Celsius studies, so many. The usage of time series modules is twofold. First is to obtain an understanding of the underlying forces and structure that produce the observed data. And the second is to fit a model and proceed to forecasting, monitoring, or even feedback and feed forward control. What are the variations in time series? There are four types of variations involved in time series analysis, and these are secular trend, cyclic fluctuations, seasonal variations, or irregular variations. You have seen, you have heard it at the end of Unit 30. There are two types of calculations. A secular trend or long-term trend. In secular trend, the values of variable tends to increase or decrease over a long period of time. The variables may be population, sales, cost of living, death rate, and so on. The trend includes steady movements over a fairly long time and does not include short-time oscillations. The trend may be in the form of slow, fast increase or decrease of the values. These changes occur as a result of general tendency of the data to increase or decrease as a result of some identical influences. You are very well aware of that nothing is stagnant or stationary. Values keeps on changing. This trend is most commonly seen in the data related to economics, business, and population. Then comes your cyclic fluctuations. The cyclic fluctuations refers to regular swing or patterns that repeats over a long period of time. Cycles are the upwards and downward movements about the trend line over a period of time. The movements are considered cyclic if the fluctuation occurs after the time interval of more than 1 year, and it can be as many as 15 to 20 years. In generally, the cycles are not regular. They may have different periods and intensity or the amplitude. The most common example of cyclic fluctuation is business cycle. The cyclic variation are affected by erratic, irregular, and random forces, which cannot be separated to measure their impact accurately. Parameters are always included in it. Then comes your seasonal variation. Seasonal variation involves pattern of change within a year that tends to be repeated from year to year. For example, sales of ice cream increases during summers. As these variations are regular patterns, they can be predicted fairly accurately. Some factors that causes seasonal variations are number one, season and climate. Changes in climate and weather affect the sales of many products. For example, sales of coolers and ACs is always more during summer. Customs and festival. Traditions and customs are also affect the pattern of the sales. For example, sales of paints and furnishing goods is more during Diwali. Sales of sweets is more during festivals. Irregular variations. Irregular variations are rapid, unpredictable, and random changes in the data. The changes are caused by some short term, unanticipated, and non recurring factors. Incidents like wars, strikes, floods, famine, earthquakes, etc. The effect of Iraq war and terrorist attack on crude oil prices is an example of irregular variations. Then comes your decomposition of time series. Analysis of time series consists of identification of various factors which cause the variation in the time series and separating analyzing and measuring the effect of these factors independently. The objective of decomposition of time series is to break time series into four components, that is trend, cyclic, seasonal, irregular, so as to isolate influence of each other of the four components on the actual series. The two common models used for decomposition of the time series are multiplicative model and the second one is additive model. In multiplicative model, we will be multiplying all these four factors. And in additive model, we will be adding all these four factors. Multiplicative model, as per the name, that is y is equal to product of all the four factors. That is t into c into s into I. It is appropriate in situations where the effect of four components is measured in relative terms rather than absolute values. And the second one is additive model. That means you have to add. This model is less common. It is appropriate in situations where variations in the time series and are in absolute values and can be separated to each of the four parts. Here, each part is independent. Each part can be negative or positive. How to measure secular trend? Secular trend measures the long-term directions of series. The study of secular trend helps in identification of a historical pattern, projecting past patterns into future, and estimating the trend components from the series. The most important method for measuring secular trend is freehand curve method, semi-averages method. Third one is moving averages method, and the fourth one is method of least square. Freehand is basically it is the simplest method. It consists of plotting the time series value on a graph paper and then drawing a freehand smooth curve through these points so as to reflect the long-term tendency of the data. This method is based on inspection, hence is subjective in nature. That is, only a specialist with long experience who knows the behavior of the variables can draw a line by a mere inspection. Semi-average method. In, in this method, the data is divided into two equal parts and arithmetic means are calculated for the each part. This is known as semi-averages. These 2 points are plotted corresponding to the midpoint of the respective class intervals covered by each part. The line joining these 2 points gives the straight line trend. The line can be extended upwards or downwards to get an estimate of future and past values. Advantages and disadvantages of this method. It is not based on personal judgment, hence, some trends will be obtained every time. Same trends can be obtained every time. It is easy to understand, and trend line can be extended downwards and upwards to estimate future and past values. Disadvantages, it is based on assumption of the linear trend. We assume that it is following a linear trend. It uses the arithmetic mean. Arithmetic mean has its own limitations, as it may not be appropriate method in some cases, depending upon the problem. Moving average method. The moving average method is based on the concept that if the observation at a point in times are averaged, out of which the values immediately before and after, it will be a smooth out and the irregular points of time series. This is very common method to determine secular trend. This method is subjective and it depends on selection of the length or period for calculating moving average. For example, 3 moving average. Sometimes we take 4, but maximum time we take 3. 4 yearly moving average, 5 yearly moving average, so as to remove the effects of cyclic variation. Then comes your least square method. You have seen it already. This is the method in which a trend line is determined using a mathematical equation of either a straight line or a parabolic curve. As this method is based on mathematical equation, it's not subjective and hence it is more accurate. The equation uses a fitting straight line as yc is equal to a plus bx, where yc is the predicted value of the dependent variable. X is your independent variable, which in this case is time. Further, A is the intercept and B is the slope. Both A and B are constants. We have the trend has the following properties. The summation of all vertical deviations from it is zero. That means summation of y minus yc will be equal to zero, as it will be the least. The square deviation of the square is minimum. That is why summation y minus yc will be least. Now fitting a straight line. The equation used for fitting a straight line is y is equal to a plus bx, where yc is the predicted value, x is the independent variable, a is the intercept, and b is the slope. Both a and b are constants. Now we will see how we have we have already seen this. I'm not doing anything new. That is now the new thing is auto regression integrated moving average ARMA. It is a model which predicts future value based on the past values. ARIMA makes use of lagged moving averages to smooth time series data. They are widely used in technical analysis to forecast future security prices. Okay, with this, we have concluded your theory part, and now we will be moving towards a brief revision of some numerical components, which is important from every point. Your understanding the subject and your application, and it will be a revision for you for the paper. I will be picking up. There are these are the basically these are the uh, these are the areas from where numerical components is normally comes. That is measure of central tendency, measure of variation and skewness, continuous probability distribution that will be related to the probability. Then comes your sampling distribute, testing of hypothesis, correlation, regression we have done today, and cheese test that was done in the last class. Now you can see this is the problem given to you. You have to draw the. I will be somewhat fast But if you have any doubt, just let me know, because this is basically a revision exercise for you. I'm just revising all those part which has a numerical component in it. This is for draw a frequency polygon for the given data. Data is given to you. For defining a frequency polygon, you should have a class size of uniform factor. That means you can see at the top that is 500 to 600. That means, and it is price less than. You have to make convert into a price. So you have to and see the difference. That is differences of 100 units. You will start from 500 to 600, 600 to 700, 700 to 800, 800 to 900, and 900 to 1000. Now, convert this data. In the first part, you will get 25. From 500 to 600, it is 25. And from 700 till 700, it is 55. But it will be 55 minus 25, 30 for your this part. Similarly, subtract this. Similarly, subtract this. And similarly, subtract this. When you will be adding all these values, you will be getting this 150, because the price is less than, and you have to convert into a normal price. Then you have to plot a histogram, frequency polygon. Start from 500, move till 1000, draw histograms, and join the center of these points, top center. You will be joining it like this and extend this line downwards and extend this line here. This is how your frequency polygon is drawn. Now we have to calculate the mean. Now see, as I had been telling you, depending upon the nature of the question, you have to identify the formula. Here you can see, I'm talking about the mean. You have to see that what is the frequency. Frequency is a single digit number. So straight away you can, by calculating the mid value, multiply it and proceed. Mid values will be 140. Mid value is of this interval. 140 plus 150 divided by 2. 290 divided by 2 is 145. See the difference of 10. Add straight away, add 10 to all. 145, 155, 165, 175, 185. And multiply these two numbers, fx. Then you have to apply the formula summation fx upon summation f, which comes out to be summation fx is 4235 and summation f is 25. Dividing it, you will be getting 169.4 as the mean. Now here, see what is happening. Frequency is too big. Number of firms is too big. And your monthly sales difference is 150. That's okay. Now what to do? See the formula. First of all, you have to calculate the mid value. Again, I'm telling you, add these two numbers, divide by. Is the slide visible now?
So it's visible.
This is the problem now. You can see that here the frequency is big, a two-digit number. That means we have to straight away change the formula. First of all, you have to calculate the mid value. Mid value is calculated by 0 plus 150 divided by 2. That comes out to be 75. You can see here the differences of 150. Add 150 to all these numbers simultaneously. 75 plus 150 is 275. 275 plus 155, 325. Similarly, you will get all these numbers. Now, there are 6 observations. Either you can take third one or the fourth one. Answer is not going to change. I've taken the third one, assume it as A, and straight away in front of it, because you have to calculate D. D is x minus 375 divided by 150. Don't have to do calculation again and again. Straight away, whatever the row you have assumed it, straight away write 0. Above it, minus 1, minus 2. And below this 0, 1, 2, 3. Multiply FD. We will get this number. Go back to the formula. X bar is equal to A plus summation FD upon F into Y. A is your 375. Summation FD is 1. Your I is 150. And your summation F is 135. Mean comes out to be 376.11. Now we have to calculate median. Frequency is 14875. For frequency, you have to calculate, for median, you have to calculate cumulative frequency. So I am again repeating how cumulative frequency is calculated. This data was given to you. For calculating cumulative frequency, you have to write cumulative frequency 1 in front of this one. Straight away add this 4 to it. Write 5 over here. 5 plus 8, 13. 13 plus 7, 20. 20 plus 5, 25. This number and this number has to be same. Now, for calculating median, you have to calculate first of all n by 2. N by 2 is 25 by 2, which is 12.5. Come to this column C, find out a number greater than 12.5. 12.5 is 13. Mark this as FME. Above it as CF. Now you have the formula L plus N by 2 minus CF upon F into I. Your L will be this 160. N by 2 will be 12.5. CF of this will be 5. Frequency will be 8. And the difference between these two, that is I, will be 10. After calculation, you will get 169.375. This is how median is calculated. Now for the calculation of mode. For a single problem, I'm finding out all the values. Now mode. For mode, you have to calculate this formula. Find out the term which is having the maximum occurrence or maximum frequency. This is, in this case, it is 8 and the class is 160 to 170. Now I will be showing all these values. Maximum frequency is in 8. Above frequency will be Fm minus 1 and below will be Fm plus 1. Your I is 10. All the values are known to you, and your LMO will be 160. Lower limit of this, move to this formula straight away. Write the formula. You will get 168 because all the values are known to you. Fm will be that value which is occurring most of the time. Mode is basically that value of the observation which is happening maximum number of times. Now we have an empirical relation between mean, mode, and median. Using the empirical formula between mean, mode, and median, you have to approximate the value of mode when mean is 5312.12 and your median is 5413.04. First of all, what is the empirical relation? Empirical relation is mode is equal to 3 median minus 2 mean. When you will be calculating all, you will get 5614.88. Your relation between mode, median, and mean is mode is equal to 3 median minus 2 mean. Now, a very interesting thing, how to draw a pie chart for respondents reply on buying a body perfume ABC. This value is given to you. Now, first of all, you have to calculate the percentage of respondents. That means 280 divided by 1000. 160 divided by 1000. So you will get this percentage. When you will add up, you will get 100. Now, what is how to calculate the degree of the pie chart or degree of the angle on the pie chart? 1%, remember 1% is equal to 3.6 degrees. 1% is equal to 3.6 degrees. Multiply 28 by 3.6, you will get 100.8. Similarly, multiplying 16 by 3.6, you will get 57.6. And similarly, all. When you will be totaling all these values, you will be getting 360 degrees. A complete circle is of 360 degrees. Now, here it comes. You draw a circle with appropriate radius and mark these 6 values with different colors, different shadings, and different angles. Now, we will be talking about variations and skewness. The following data is for the sales made by different companies in a year. Calculate the quartile deviation and its coefficient. Is this an appropriate measure for the study of measurement of variability? Comment on it. This is the data given to you. You have to find the Since you have to find the quartile deviation, you have to calculate the cumulative frequency. I hope everybody knows now how this cumulative frequency is calculated. First of all, you have to calculate Q1, Q3. And the Q1 is n by 4. Your n is 60, 16 by 4 is 15. In the cumulative format, cumulative frequency column, find out a number as 15 or greater than 15. You have 15 over there in the second row. That means your group will be 40 to 45. And similarly for Q3, you have to calculate 3n by 4, which will come out to be 45. So here a number is 48. That means your median class or your class will be 55 to 60. I will be using the relation Q1 is equal to L plus n by 4 minus Cf upon F into I. And for Q3, it is L plus 3n by 4 minus Cf upon F into I. After imparting the values, you will get two values. One as of Q1, that is 45, and Q3 as 60. Your quartile deviation will be Q3 minus Q1 divided by 2. That comes out to be 7.5. Now you have to calculate coefficient of quartile deviation, that is Q3 minus Q1 upon Q3 plus Q1, which comes out to be 0.142. Now you have to calculate Bowley's coefficient of skewness and Carl Pearson coefficient of skewness. This data is given to you. Now, this is because in that you have to calculate mean, median, standard deviation, everything has to be calculated. Now, since you have seen that frequency is too large, so we have to apply the formula D is equal to x minus a into y I. First of all, you have to calculate the mid values. In the center, you will find that I have marked this at the third value, as I've assumed that A is equal to 750. In front of that, I will straight away write 0. Above it, minus 1, minus 2. And below 0, I will be writing 1, 2, 3. First of all, I will be squaring D square. Then I will be calculating FD square. Then FD and then CF. Because for mean, I have to apply the formula mean is equal to A plus summation FD square upon N into I. For standard deviation, I have to apply under root fd square by n minus summation fd by n whole square into I. And for median, I have to calculate L plus n by 2 minus Cf upon f into I. After placing up the values, and for the mode, I do have that value that I've calculated mean and median. I can calculate mode from it, but to make it an exercise, I've used the formula. Now I'm having mean, mode, and median. Your mean is 766.6. Your mean is 755, and your mode is 744. You can see 744, 755, and 766 almost equal. Now we have to calculate trial Q1, L plus n by 4 minus Cf upon F into I. Place up the values 680. For trial 3 is L plus 3n by 4 minus Cf upon F into I. That comes out to be 850. Now, Boli's coefficient of skewness, mean minus mode upon SD. You will get the value as 0.18. And for the same problem, I am calculating Karl Pearson coefficient of skewness. After putting up the values, I get 0.18. Almost same. Whatever the method, the formula we apply, the answer is not affected by it. Marginally or partly it is affected, but mathematically it is assumed to be same. For Boli's coefficient of skewness is 0.18 and your Karl Pearson coefficient is 0.11. Now I'm taking a problem on probability. A problem in statistics is given to three students A, B, and C, whose chances of solving the problem are 1 by 2, 1 by 3, and 1 by 4. Find the probability that the problem is solved. Try to understand a problem in statistics is given to three students. Three students, individual probability of solving the problem is 1 by 2, 1 by 3, and 1 by 4. Now, your first question is the problem is solved. And your second question is at least two of them are able to solve the problem. And the third one is exactly two of them are able to solve the problem. See the difference. Don't get confused. The problem is solved. That means at least one of them have solved it. What we will be doing? We will be subtracting the product of the three respective probabilities from 1. That means they won't be able to solve it. So 1 minus 1 by 2 is 1 by 2. 1 minus 1 by 3 is 3 by 2 by 3. And 1 minus 1 by 4 is 3 by 4. That means what will you do? 1 minus 1 by 2 into 2 by 3 into 3 by 4, which comes out to be 1 minus 1 by 4, which is equal to 3 by 4. Second part is at least two of them are able to solve the problem. And that means what I will be doing. We have a very, very big relation for it. You can see that one has solved the problem. What was the problem? That the problem at least two of them, two product of two of them into non solving probability of the first one. And there will be three cases. So we will be getting 7 by 24. And the third one, that means for the third problem, You have a formula, exactly one of them are able to solve the problem. That means you will be using the third formula for it. These are the standard results. I'm just showing up the application for it. Now see, assume the mean height of soldiers to be 68.22 inches and a variance of 10.8 inches. How many soldiers in the regiment of 1,000 would you expect to be over 6 feet tall? The given value of Z for the area between 0 and 0.0 and 1.15 is 0.3749. This value is given to you in the problem. Now, it is a problem of probability. Mean is given to you. See how I am relating it. Mean is given to it. Variance is given to it. I have to find standard deviation. For standard deviation, I will be doing under root of it. Okay. Now these two values are given to me. That means it is a case of normal distribution. And what I have to find? A regiment of 1,000 is expected to be over 6 feet tall. That means my x will be 6 feet. The mean is given in inches. I have to convert this feet into inches. 6 feet is equal to 72 inches. Now, we have to calculate Z. Z is equal to x minus mu upon sigma. This is the standard result. 72 minus 68.22 divided by under root 10, which comes out to be 0.3749. Plot it. Here it comes. What was the problem? Problem was how many soldiers in the regiment of 1,000 would be expected to over 65 6 feet tall. 6 feet tall means that you will be taking that area on the right which has been marked in color. That means zero point 0.5 minus the probability of it, what is given to you, the value of z from the table. That is 0.3749. After subtracting, you will be getting 0.1251, which is 12% of the soldiers will be over 72 inches. Therefore, the required number of soldiers in the regiment of 1,000 will be 1,000 into 0.1251, which comes out to be 125. Here, this is the complete answer of the problem. You remember Bayes' theorem. A car manufacturing factory has two plants, X and Y. Plant X manufactures 70% of the cars, and plant Y manufactures 30% of the cars. 80% of the cars of plant X and 90% of the cars of plant Y are rated to be of standard quality. A car is chosen at random and it is found to be of standard quality. What is the probability that it has been drawn from plant X? So these are the probabilities. PB1 70 by 100, and I had already told you to simplify it so that everywhere in every number your denominator should be same, because it will be easier for you for calculating. I'm just converting 70 by 100 to 7 by 10, and probability of B 30 by 100 by 3 to 3 by 10, and probability of getting a standard card from plant 1 as 80 by 100, so I'm just converting into 8 by 10. Similarly for B, I'm converting into 9 by 10. My problem was calculating that it came from plant 1. What I will be doing? I will be multiplying this one by this one and dividing it by sum of respective probabilities. That means product of sum of the respective probabilities. 7 by 10 into 8 by 10 plus 3 by 10 into 9 by 10. Here you can see it is written. It will come out to be 56.83. And for the second, similarly, for the second it will be 27 by 83. I'm just testing a problem with you for testing of hypothesis. A typist claims that he can type at the rate of 120 words per minute. Can we reject his claim on the basis of 100 trials in which he demonstrates a mean of 116 words with standard deviation of 15 words? We have to use 5% level of significance. So first of all, it is related to testing of hypothesis. The null hypothesis will be that the typist claim is true. Mathematically, it is written as h naught is 2 mu is equal to 120. And the alternative hypothesis will be h1 is 2 mu is not equal to 120. It is a case of two-tailed test. Your n is 100, x bar, that is mean, is 116, and your mu, that means mu is 120, and your sample size is 15. Our standard deviation is 15 because we are taking for the sample. So first of all, we have to calculate standard mean error, that is sigma upon under root n. Your sigma is 15 divided by under root n is 100. 100 under root 10 is 100. Under root of 100 is 10. That means your standard area error comes out to be 1.5. Test for statistics, that is equal to x bar minus mu or m upon s divided by under root n. These all relations have been told to you when we were discussing about the testing of hypothesis. This value comes out to be 2.67. Now, level of significance alpha is 0.05. Your statistical value is 1.96 from the table, and your calculated value is 2.67. Your calculated value is greater than the tabular value. That means you have to reject your null hypothesis. After rejecting the null hypothesis, the conclusion is that the claim made by the typist that he can type at the rate of 120 words per minute is incorrect. I will show you one more example. It will be regression we have done today. Okay. I'm just doing the converse of application of regression and correlation because it can be asked in any form. The random variables have the least square regression lines, this and this. You have to calculate the mean value and the coefficient of correlation. Your equations are in the standard form. First answer. Find out the value of x and y by solving it simultaneously. As soon as you get the value of x and y, that will be the mean. Number one, x in this problem, x is equal to 4 and y is equal to 7. That means your mean of x is 4 and for y it is 7. First part has been concluded. For the second part, convert this equation 3x plus 2y is equal to 26 in the form of y is equal to mx plus c or y is equal to bx plus a, whatever you take it. So the coefficient of x will be byx equal to minus 3 by 2 in this case. And for the second equation, we will be converting that in terms of y. So here it will be bxy is equal to negative 1.6. You remember it? I told you the sign of byx and bxy will be same. Here you can see that minus 3.3 by 2 in the first case and negative 1 by 6 in the second case. What will be the value of r now? You have the value of bxy and byx. That was the geometric mean. Under root product of 3 by 2 and 1 by 6. That comes out to be 0.5. Since bxy and byx both are having negative sign, that means your r will be, the value of r will be negative 0.5. That is the value of r. With this, I will be concluding today's session. अब आपको कुछ पूछना है तो आप पूछ सकते हैं मुझसे, बिकॉज ये आपका आज का आखिरी सेशन था. Any question? Any question from anyone, or I should conclude this session? You have any question, or I should conclude?
About others, I don't know.
I didn't get you. आप क्या कह रहे हैं?
Sir, can you hear me?
Please write your question. Should I conclude it? Okay. Thank you, and all the best for your exam. Bye bye.
Sorry, sir, for the delay. Actually,
Bye.
मेरा इंटरनेट ठीक से काम नहीं कर रहा था. सो सर, जैसे कि आपने कहा, ये हमारा लास्ट क्लास था और इसके आगे एग्जाम्स होंगी. कुछ डिटेल्स सर अगर एग्जाम के बारे में हमें मिल जाए कि एग्जाम्स में कौन से यूनिट आने वाले हैं.
नहीं, देखिए ऐसा है कि एग्जाम्स में ऐसा कुछ नहीं होता. इन द एग्जाम की जो एक्चुअल डेट शीट है वो आपके एलएमएस पे आएगी, नंबर 1. नंबर 2, as far as the important part is concerned, it's very difficult for anyone to predict the important part. Whatever has to be done, it is an applicative paper and it will have a numerical in it. So because this is mathematics, so no doubt numerical will be there. So you have to be careful with the numerical part.
और ऑप्शंस क्वेश्चंस होंगे, जैसे कि 4 ऑप्शन आते हैं जिसमें से 3 गलत होते हैं और 1 राइट होता है, जैसे कि ईडीएक्स में होता है या कोर्सिया में जो अदर ऑनलाइन अथॉरिटीज हैं, जैसे कि वो एग्जाम लेते हैं. हमारा भी वैसे ही होगा या हमें सब कुछ लिखना पड़ेगा सर?
You will be asked to write
all the questions. We don't have anything to select.
Now, in the questions, what I think in the questions, number of questions, suppose in part A there are 4 questions, you will be asked to do 3 or 2. You may be asked. It can be a pattern of it, but it won't be an MCQ part. It will be a theoretical paper.
And no clue. Clue tip कुछ नहीं मिलेगा सर. गुप्तम क्लू टिप कुछ भी नहीं मिलेगा कि हमें कौन सी यूनिट पे ज्यादा फोकस करना चाहिए, कौन सी यूनिट पे नहीं करना चाहिए. हमें सब कुछ 100% पढ़ना पड़ेगा एग्जाम के लिए.
इसलिए ऐसा है कि मैंने अभी थोड़ी देर पहले इसी सेशन में आपको ये बताया था कि ये वो पार्ट है जहाँ पे न्यूमेरिकल कंपोनेंट होता है, और कुछ न्यूमेरिकल को मैं अभी भी मैंने बताया। तो न्यूमेरिकल कंपोनेंट आप सही करेंगे तो आपका काफी हद तक पेपर आसान हो जाएगा, क्योंकि मैथमेटिक्स है, बगैर न्यूमेरिकल के नहीं होती है।
नहीं हो पाएगा जी सर। थैंक यू सर, थैंक यू सो मच, इट वाज रियली गुड टू नो यू एंड वी रियली हैड अ गुड टाइम। धन्यवाद सर, थैंक यू।
धन्यवाद सर। एनी अदर? हाँ मिस्टर
Sir,
मासूम,
thank you.
what is?
Yes, sir. I have. Thank you for your useful presentation from the start to end. And I think today will be the last session, and our class, I think, was completed. But when sir share the presentation with us,
I
I
will
mean
be
the
sending
PowerPoints.
the uh, this PowerPoint to the authorities today or by tomorrow. They will be sending it to you.
Thank you, sir.
And sending to all of you, not to you.
Okay,
It will be to all of you.
thank you.
Okay, all the best. Yes. Anyone else? Okay. Bye bye. I'm concluding this session.